Okay, so the question here says, what are the first 5 terms of the sequence where a sub 1 is equal to 2 and a sub n is equal to negative 2 times a sub n minus 1? Okay, so a1, that stands for my first term in the sequence. Okay, a sub n is my general term. So any term that I want to find, I substituted here. Whether I want to find the second term, the third term, the fourth term, the fifth term, or even the sixth term, I substituted in for n. Okay, that's the term that I want to find. All right, so let's get to working on this problem. It says a sub n is equal to negative 2 times a to the sub n minus 1. Okay, so a sub n is equal to minus 2a sub n minus 1. Now I just said that we want to find we want to find the first 5 terms. So we already found the first term, which says here the first term is 2 because a sub 1 is 2. Okay, now I want to find the second term. Now the second term here is what we do, we substitute the term that we want to find, which is 2, in the place of this n. Remember I said we substituted in the place of this n everywhere in n. So it'll be a, let's find the second term. So it's going to be 2 is equal to a minus 2 times a times n. What did we say n was? We said it was 2 in this case. 2 minus 1. Now this is a subscript down here. So it'll be a sub 2 is equal to a minus 2 times a. 2 minus 1 will be what? 1. So we're looking at a sub 2 is equal to a negative 2 times, what's a sub 1? We just said a sub 1 up here is 2. So it'll be a sub 2 is equal to negative 2 times a positive 2, which will give me a minus 4. Okay, so this says that this is my second term in the sequence. Perfect. If you, I'm going to do a second one, then you'll see a pattern here that we can recognize. All right, now let's do this one. We want to find the third term. So a sub n is equal to a minus 2a sub n minus 1. Okay, so it'll be a sub, what term we want to find? The third term is equal to a minus 2 times a. We want to find the third term, substitute the 3 in for n also. Subtract 1. So we have a 3 is equal to a minus 2 times a. 3 minus 1 is 2. So we have a sub 3 is equal to a minus 2 times a sub 2. What's a sub 2? We said it's negative 4. So I have a sub 3 is equal to negative 2 times a negative 4, which will give me a positive 8. Now, what I actually did here, if you can see a pattern, this part here, n minus 1, basically means use the previous term. Okay, so let's go ahead. So we found a third term. So let's put our third term up here. That'd be an 8. Okay, this 4 should be negative here. Okay, so this be an 8. Now let's find our fourth term. So we don't have to rewrite this. Let's write a sub n is equal to a minus 2 times a sub n minus 1. So I have a, I want to find the fourth term, is equal to a minus 2 times a. I want to find, this is the fourth term, right? So I'll substitute a 4 for the n, minus 1. Okay? So this will be a sub 4 is equal to a minus 2 times a. 4 minus 1 is 3, so it's a sub 3. So a sub 4 is equal to minus 2 times a sub 3 is 8, right? So a sub 4 is equal to a minus 2 times 8, which will give me a minus 16. Okay, that's my fourth term. Now I said find the first 5 terms, so we need to find one more term. Okay, you can see a pattern here: positive, negative, positive, negative. So we can induce that this next one would be a positive. Let's try it. A sub n is equal to a minus 2 times a n minus 1. So a, let's get up. Well, we want to find the fifth term. Perfect. Is equal to a minus 2 times a. We want to find the fifth term. So n is 5, so 5 minus 1. This means the previous term before that. So basically it's 5 sub a. A sub 5 is equal to a minus 2 times a. 5 minus 1, like I said, this means the previous term that you want here. You want the previous term. So what's the previous term? 5 minus 1 is a sub 4. So you're looking at a sub 5 is equal to a minus 2 times a sub 4. We just said over here is minus 16. Perfect. So now we have a sub 5 is equal to a minus 2 times a minus 16, which will give us a positive 32. And this would be my fifth term because I have n is 5. That means my fifth term, okay? So it'd be 32. Now, let's recap here a little bit. So basically, this n basically means the general term, the number that I want to find. So if I want to find a to the 100th, then that means I would have to do, substitute 100 here, and then also 100 for this n here. So we'd actually be having, let's go ahead and find the 100th term of this sequence here, is equal to a minus 2 times a, right, times n, which we say n was, it's 100, minus 1. Look, what do we have here? We have a sub 100 is equal to a negative 2 times a, 100 minus 1 is 99. This says a 99. We don't know what a 99 is, and it's so much to sit here and find what the 99th term is, because in order to find the 99th, we have to have the 98th, and in order to have the 98th, we have to have the 97th. So basically, this sequence here is called recursive. You have to use the previous term in order to get the next term. If you can remember from Pascal's triangle here, 1 2 1 1 3 3 1 1 4 6 4 1, and it goes on and on and on. We must have, at this being row 0, this being row 1, this being row 2, this being row 3, and this being row 4, we must have the previous term, the previous row, in order to get this next row. Same thing with recursive sequences. We must have the previous term in order to get this next term here. So in order to get the 100th term, we must know the 99th term. In order to get the 99th term, we must know the 98th term. But yes, this is called a recursive sequence. Okay? And here are my 5 terms that we found for this question here. What are the first 5 terms of my sequence? Where a sub 1 is equal to 2 and a sub n is equal to negative 2 times 8 sub n minus 1. It's 2, negative 4, 8, negative 16, and 32. Real quick, let's talk about the rule. The rule would be multiplying by 2. 2 times 2. By negative 2. So negative 2 times this 2 would give me a negative 4. Negative 4 times negative 2 gives me a positive 8, times a negative 2 gives me a minus 16, times a negative 2 gives me a positive 32. So this rule is negative 2.